In this video, I want to introduce some of the important array operations that one could use in MATLAB. For doing this, I'll be using the following three arrays or matrices. Notice that array A and array C is of the same shape, so it has the same number of rows than columns, where array A and B, A has the same number of rows than columns for B, and obviously the same number of columns than B has rows. So it's just the inverse of A in the shape. Okay, so this is important to remember when you look at different array operations. The first operation I'm looking at is that of array multiplication. The rules for array multiplication to be legal or to happen is that in this case the number of rows of A must be the same as the number of columns for B, and the number of columns of A must be the same as the number of rows of B. And the size of the answer is the number of rows of A, the one on the left hand side, and the number of columns of B, the one on the right hand side. So you'll end up with an answer which has 2 rows and 2 columns. So if we calculate row 1, column 1, what we look at is the first row of A and the first column of B. And then we simply say 2 times 2 plus 3 times 4 plus 4 times 8, which gives us 48. So you go down the row and down the column and you multiply the elements with each other and then add the answer. So you'll notice that 48 is now in the first row and the first column of the answer. Now we want to calculate the first row and the second column of the answer, so we look at the first row of A and the second column of B, and we do the same. 2 times 4 plus 3 times 5 plus 4 times 6, which gives us 47. So we go down the first row of A and down the second column of B. This pattern we keep on applying. The second row of the answer and the first column of the answer, we use the second row of A and the first column of B. So it's 5 times 2 plus 6 times 4 plus 7 times 8, which gives us 90. Then the second row and the second column of the answer is the second row of A and the second column of B. We apply the same recipe and we find that that value is 92. So the final answer of A times B, normal array multiplication, is 48, 47, 90, 92. Notice if we try to multiply A with C, so we're applying array multiplication on the A and C, they have the same shape. So the rules for the multiplication to happen is not existing. So this is impossible. We cannot do a array multiplication between two arrays that have the same shape. The second array operation is the dot multiplication between two arrays. And in this case we're doing it between A and C. And now for the dot multiplication, which we also call element by element multiplication, they must be of the same shape. So the number of rows in A must be the same as the number of rows in C, and the number of columns in A must be the same as the number of columns in C. And the answer also then has the same shape. So row 1, column 1 is calculated by multiplying the first row and the first column of A, that's 2, by the first row and the first column of C. So 2 times 5 gives me 10. And notice that we put 10 in the first row, first column of the answer. We continue with this. So when we find this first row, second column of the answer, we multiply 3 with 6, the first row, second column of A and C, which gives us 18. And we repeat this for the first row, third column, which is 4 times 7, which will give us 20. Applying the same recipe for the second row of A and C, we end up with 10, 12, and 14, and that is our answer. It has the same shape as A and C. The next scenario I want to look at is when you do a multiplication with an array, but one of the operands is a scalar value. In this case, it's called a scalar value or a single value. In this case, it's the value 5. So when one of your operands is a scalar value and the other one is an array, the dot multiplication and the normal multiplication both are element to element. So notice 5 dot multiply a and 5 times a is the same thing now. So you start off with a vector that has 2 rows and 3 columns, and you end off with an answer that has 2 rows and 3 columns, simply because one of the operands is a scalar value. The addition of 2 arrays, the plus, is always an element addition, so you don't have the concept of a differentiation between a plus and a dot plus. It's plus and it's element to element, which means the 2 operands, in this case a and c, must have the same shape. So you can't add a to b because they're not the same shape, and you literally just do element to element. So it's 2 plus 5 will give you 7, then 3 plus 6 will give you 9, and 4 plus 7 will give you 11, and you do the same for the second row, which ends up to be 7, 8 and 9. The exponential operation is always also element to element, but in this case you have to say dot exponential. So you can't just say the exponential sign on its own, operation on its own between 2 arrays. You've got to say dot, and because it's element to element, the 2 arrays must have the same shape. So what we get here is for row 1, column 1, if it's a dot exponential c, it's 2 to the power 5. Then it's 3 to the power 6 and 4 to the power 7. Notice the way that we use it more often is using a scalar operator. So the third example there is a dot exponential 2, where you simply take the values of a, each element of a, and you power 2. So it's 2 to the power 2, 3 to the power 2, 4 to the power 2, and you do the same with 5, 6, and 7. There's no concept of just a exponential 2. So the exponential operator always has the dot in front of it. The dot division, the element to element for operator for division, also applies between two arrays which have the same shape. So you can't say a dot divide b because they don't have the same shape, but you can say a dot divide c. Notice you have the forward slash and the backward slash. The forward slash is just like a normal divide. So a dot divide c will take the first element in row 1 of A and divided by the first element of row 1 in C. So you'll have 2 divided by 2, then 4 divided by 2, then 8 divided by 2. If you however use the backslash for the division instead of the forward slash, it just does it in the reverse order. So it's actually, you could say dot division C divided by A. So now you'll see in that circumstance you have 2 divided by 2, then 2 divided by 4, then 2 divided by 8, etc. So the forward slash is the normal order, the backward slash is just the reverse order. So you're dividing the first operand into the second operand. So as a summary, what is the element to element operations for all the examples that we've looked at? When you do multiplication, it's the operation dot multiply when both the operands are arrays. When one is a scalar, you simply just say multiply. For addition and subtraction, it's just the plus and the minus sign, but it's still element to element. For division, it's dot divide, and it's either a forward slash for normal order or a backward slash for the reverse order. And for exponential, it's dot exponential, and whether one of the operands is a scalar or not, you have to put in the dot. You can't just say a exponential 2. That won't work.